Hey guys, thanks for coming back again. If you're a subscriber of this channel and if you are new here, just click on the subscribe button and also don't forget to turn on the notification bell. That will let you know when we drop our video. So we are bringing to you a little about the physics practical mechanics. Here we have a beaker filled with water, then we have a spring balance and retort stand. So we want to carry out this little procedure. Then we have what's it called, the retort stand. We have a liquid label L. We don't know the liquid anyway, no problem. So probably the experiment is aiming at looking for the relative density of that liquid. So it is liquid L. However, let's follow these procedures. Let's read it before we go into the experiment in detail. Now we have studied the above diagram and used them as guides in carrying out the instructions. So the first one says that using the spring balance provided, determine the weight of the object of mass m equals 50 grams. So we are going to hang a mass of 50 grams on this spring balance and measure the weight in air. So that weight in air will be recorded as weight 1. Then determine the weight of the object when immersed completely in water. And we are recording that weight as weight 2, just like what this first diagram is trying to interpret for us. We are recording this, the weight we measure here in water, as weight 2. Then we go again we determine the weight of the object when it is completely immersed in liquid air. So we record that weight as weight 3. So in each case, we are meant to do certain thing. So in each case, we are meant to evaluate U. So U represent weight 1 minus weight 2, and V represent weight 1 minus weight 3. To see the difference between the weight in air and water and the difference between the weight in air and liquid air. So then we have to repeat the procedure while changing the masses from 50 to 100, 100 to 150, 200, and then 250. So don't forget, in each case we have to evaluate our U and V, just as I've said. Now, just as it is, physics practical always have to do with graphs. So we have to make a table of our values and then plot graph of V on vertical axis and U on horizontal axis. Then determine the slope of the graph. So the slope of the graph might actually be the relative density of that liquid. So then we have to take 2 precautions to obtain accurate results. Well, that is very simple to do. Let's go and check the practical. So now this is the spring balance, and this is the liquid L, and this is water. So we are going to immerse the mass in each one of them. So this is 50. So let's take the measurements in air. So it's giving me 50 exactly. Mind you, this spring balance is always calibrated in gram and in Newton. So if yours is calibrated in Newton, just read the value of Newton as your weight. And if yours is calibrated in grams only, all you need to do is multiply whatever value you have here by 10. You get your weight. So that is the way it is. Then, so here now I'm having the weight to be 45. I'm having 45 as the weight in this particular liquid air. So the weight is 45. So what I'm saying is 45. So let's move to when it is 100. So I have to double the mass. So doubling the mass, I have 100. That's 2 of 50. That's what I will have to use. 2 of 50. So let's weigh this in air. That's 100 grams. So it gives 100 in air too. It gives 100 in air. So good. Now let's measure in water and see. Let's measure in water and see. Okay, it reduces to 90. So that will be 900 Newton. That will be 900 Newton. So then we go again to the liquid L. So then we have 95. So I think this is a regular interval stop. So it gives 95. Then the next is, let's go to 150. So for 150, the weight is 150, just as we can see. It's exactly on 150. So that's it, 150. So then we go again to measure it in water and see what we have. So when we measure in water, we have 149. Sorry, 140 rather. So that's interval of 10. It's 0 with 5 lines to 50, so it's interval of 10. So this is 140. So let's move to when we weigh it in liquid L. In liquid L, I'm having okay, it's giving me 145. So that's it. So then we go to 200. This is quite easy. 200, sorry. So this is 200. So let's weigh in water and see what happens. I would even love to be lifting this upward so I can put my liquid and then drive it down. It should be immersed completely. So this gives me a value like that's one. So this gives me 180. So let's go to the last one. Okay, I mean in solution L. So that's 185. So let's hang the mass 250. So these are the values on the table. Though majority of the values are adjusted because there are some errors on the spring balance, so of which I don't want to waste too much of time in the video. So then we just have to plot our graph of U and V. So V will be on the vertical axis and U will be on horizontal axis. Let's see what the graph seems to look like. So this is the graph. We have the graph title, graph of V against U. Then we have the axis. On U axis, don't use X and Y, please. U axis 4 centimeter to 50 Newton. V axis 4 centimeter to 50 Newton. So then this is the U axis and this is the V axis. So I'll fix the value now. When we have on U we have 200, on V we have 100. So 200 to 100. So 100 falls somewhere here. So that's the marked point. Then when U was 100 we have 50. When U was 100 we have 50, so that falls here. Then when U is 150, the other is 100, so we have this. Okay, good. Then when we have 150 on U, we have 100 on V. 150 on U. Okay, when we have 200 on U, we have 150 on V. 200 on U, 150 on V. So we have 200 to 150, so 150 falls here. Then the next one is 150 to 50, 150 down to 150 on U, down to 50. Yeah. So it's time to choose the best fit line. The graph is scattered, so there might be errors in little errors in the experiment, but I can see a very good line I will use. So I've plotted the graph. Actually, the number of points that fall on your graph also it determines the mark you are going to get in your exam. But due to one or two factors and errors in my experiment here, due to means of improvising for one or two things, I could get 3 points that falls on the line. So then I will determine my slope and find my answer. So my slope here is giving me 1, so which is this one represents the density of water anyway, but the relative density anyway. But however, we can just put that in 2 decimal place, 1.00, and okay, that's my slope, 1. So I was expecting something like 0.8, though close to 1. Probably that's an approximate value. So that's it. Thanks for watching. Please subscribe to the channel and share the video. Thank you.